In terms of probability, right, concepts that we need to revise, especially from grade 11, like I said, is the Venn diagrams. If you can revise Venn diagrams, also tree diagrams, contingency tables, contingency tables, and your what they call dependent and independent events, dependent and independent events. Hey, I remember I was studying these things while I was on my way to write my final exam. Yeah, it was tough, but yeah, need to just revise those things, guys. Now, what we're gonna focus on today is going to be the counting principle. It's the counting principle. Now, counting principle is a way of finding the number of ways of doing something. Okay, the number of ways of doing something. And if I can start off with a very, very basic example, this is actually what I used myself when I reached varsity first year. So I had three pairs. I had three pairs of um, socks, and then I had two shirts, two t-shirts. They're called t-shirts, eh? Yeah, two t-shirts. And then I had yes, and then what? Three pair of trousers. Is it a pair? No, three trousers. Yes, three trousers. For those who just joined, welcome to today's lesson, guys. We would be discussing probability and then we're gonna swiftly move to calculus. So I had three pairs of socks, two t-shirts, three trousers, and what else? Yeah, and then two pairs of shoes. Two pairs of shoes. Now, guys, I needed a way, right? I needed a way to wear these outfits, right, without repeating any outfit. I needed a way of wearing these, you know, clothes without repeating any of the outfits. Because remember, when you reach varsity, you have to, you know, show that like ad- what do they call it, fit in with other people. So you can't be showing there with the same outfit all over and over again. So I then did this. I wrote what I had down, and then I used counting principle to find out how many outfits can I form from this. So how counting principle works is that you're going to be using um, these blocks to represent the number of possibilities. Name. So on these blocks, if here is the socks, here is the socks. Now, how many socks can I choose? How many pairs of socks can I choose to wear? I can choose any of the three. So I have how many options? Listen to the English. I have how many options for the socks? I have three options for the socks. How many options do I have for the shirts? I have two options for the shirts. How many options do I have for the trousers? I have three. And then how many do I have for the pair of shoes? I have two. Good people, when you multiply all of these, you actually get the number of ways in which you can wear all of them without repeating an outfit. So therefore, if I say 3 times 2 is 6, 6 times 3 is 18, and then 18 times 2 is 36. So I have 36 options or 36 outfits from only this. Guys, this means I can go a whole month without repeating an outfit by just using probability. But now you'll be asking, but how is that possible? Well, it's quite possible. If these are my socks here, I'm just gonna say this is one pair, and then this is another pair here, another pair, and then this is my last pair here. Right, this is my other pair there. So these are three pairs, and then my shirts, I have a blue shirt. So let's say this is my blue shirt there, and then I have a white shirt, maybe a sweater nyana, right? Maybe a sweater nyana. Oh, very beautiful. And then trousers, I can say I have let's just say this is an Adidas trouser, by the way, guys. So it's an Adidas one, and then I have a Nike one. Maybe they're like sweatpants nyana, you know. This is what I have. Okay, and then the pairs of shoes, I'm just having these ones, and then maybe a Cavella nyana just for the go. Right, so this is what I have. So guys, you can understand that I'm just gonna show you one outfit I can have from this. I can take this one, I can take this one, and then take this one, and then take this one, and then take this one. This is outfit number one. You see, then I'm ready to go. You know, I rock them at school. What am I gonna do tomorrow? Let me just show that this is Nike, and then this one is Adidas. That's my Adidas there. So then tomorrow, what am I gonna do? Instead of taking these shoes for tomorrow, now I take these shoes. This is outfit number two. The next day, maybe instead of taking this trouser, I take this trouser here. Outfit number three. That's outfit number three. Tomorrow, with this trouser, I change the shoes only. Then I can take this shoe. That's another outfit there. Ne? Yes, Miss Portia, you have a question? Right, that is another outfit there. Maybe tomorrow, ne, instead of wearing these socks, I change only the socks. And then now I'm gonna be rocking them with these socks. Oh my goodness, sorry. Eh, yeah. And let's change the socks, guys. We need these ones. Now I'm rocking them with those socks. The fact of the matter is that the more I'm having different combinations of these things, the more I have different outfits. You understand? And that is how you can use probability for your daily life. Um, ladies, you will go on dates some days, right? You will go on a date. On a date, there they will tell you that this is the dessert section. Is it dessert or dessert? So maybe they'll tell you that you have ice cream. You can choose from ice cream, and then or what I like, they can say milkshake, right? Beautiful. And then they say on the burgers here, you can choose from a chicken burger or a mushroom burger. Do you know what is a mushroom burger, guys? If you don't know, don't worry. One of these good days, you shall witness it. An orange burger. Do you know what is an orange burger, guys? Don't worry if you don't know it. One of the good days, you'll understand it. And then you have an apple burger, right? If you go to Sentin there, you can find these apple burgers. There's this nice restaurant with apple burgers. And then you can have also beef burger, or you can have pork burger, right? So all of these burgers you are allowed to choose from. That is the menu. And then they say the drinks. Well, don't worry. From the drinks, you can choose Coke, Coca-Cola, hey. Coca-Cola, or you can choose Fanta, or you can choose water, or you can choose maybe some tea and stuff. So guys, these are your options. So if I were to calculate to say how many meals can you make from these options, there are so many. And Let me show you. Because you know the thing is, men or men, we don't understand why ladies they take time to maybe like choose, you know, on a menu. Now we just want to clarify that through calculations. So how many meals can she decide to have? Right, the number of meals there, she can choose from the dessert. From the dessert, she can choose two. She can choose one of these, so she has two options, guys. This means two options, ne? This means two options or choices. Then from the beggars, you can choose either this or that or that or that or that or that. How many are they? 2, 4, 6. So you can choose 6. And then from the drinks, you can choose from the 4. Then you multiply. If you multiply, you have 2 times 6, which is 12. 12 times 4 is 48. So you have 48 meals that you can have. So you'll have to understand that someone who has 48 meals, 48 options, it's going to be super difficult for that person to choose the meal. And that's why the ladies, they usually take time and are confused. They don't even know what they should do there. You understand? But it's just about probability. But apart from just that, guys, probability counting principle, it also has many other uses. For example, let's say I have the word Cly. Let's say I have the word Cly. How many words can I form from the word Cly? How many 3-lettered words can I form from the word Cly? 3-lettered words can I form from the word Cly? Well, you just have to make 3 spaces because you want a 3-lettered word. So you say, okay, how many options do I have for the first letter? I have 3 options. Now, I tell you that you can repeat the letters. You can repeat the letters. If I tell you that you can repeat the letters, right, that is kind of like a restriction. So I'm telling you that when you are choosing the letters, don't just choose them knowing that you can repeat them. So you had 3 options for the first letter. For the second letter, you're also going to have 3 options because, for example, if I chose Y here, I can also choose it here. Or, in fact, I can also choose it there. So how many options do I have for the last one? I have 3. So if I say 3 times 3 times 3, I'm going to have 27 words that I can form from just 3 letters. 27. Is it really true? Yes, it's true. You can have Y, Y, Y. You can have C, C, C. You can have L, L, L. You can have Y, Y, C, Y, Y, L, Y, Y. Oh, it's done. Y, C, L, C, C, L, C, C, Y, LLC. Guys, you can make so many, so there are going to be 27 in total. The letters don't have to make sense, please, guys. The letters, the words, they don't have to make sense as long as it's a 3-lettered word. Wait, so if this is counting principle, are we actually using counting principle in our daily lives? Yes, you are. For example, if you take your iPhone, right? If you take your Apple iPhone, it's gonna ask you for something that is called a passcode. A passcode is a combination of numbers, and the passcode have to be 6 numbers, 6 digits for the passcode. You understand? So how many passwords can we form in the whole world? Do you know that you can calculate the number of passwords that can be formed in the whole world for people who are using iPhones? Yeah. Sorry to the Android users, but then we can calculate all the passwords that are in the world. How many can we have? So for the first number, remember you have to choose from 0 to 9. How many numbers are there from 0 to 9? These are 10 numbers, right? These are 10 numbers. So since there are 10 numbers, for the first part here, I can choose any of the 10. I can choose 0, I can choose 1, I can choose 2, I can choose 3, I can choose 4, I can choose 5, I can choose 6, 7, 8, 9. You understand? So I have 10 options. What about for the second digit? I still can use any of, because these digits are allowed to repeat. So I can still choose from any of the 10. Even here, I can still choose from any of the 10, from any of the 10, from any of the 10, from any of the 10. Now, if you multiply them together, you can get the total number of passwords that exist for all iPhone users. So that would be 10 times 10, 100 times 10. Yo, guys, let me use a calculator. So that would be 10 times another 10. 6 times, okay. So that is 10 to the power 6, ne? 10 to the power 6. Now this calculator of mine, it doesn't do those powers, eh? So let me just grab one real quick. Right, so but you will see that it's a very large number. So it's going to be your 1, how many? 1, 2, 3, 1, 2, 3. Oh, so you simply have 1 million passwords. Wow, what a beautiful number. So you have 1 million passwords that you can have that are for all the iPhone users in the world. That's a very beautiful number. I think whoever was doing that passcode for iPhone was like, wow, let's make them have only 1 million passwords. But the thing is that you can try all the if you want to unlock an iPhone that you found on the street and you want to unlock it, you can try all the passwords from 1 to 1 million. There's one that is going to work, guys. Okay, so we now just have to try them first. Maybe you can say 121001. This is 1. You try again, 121002. That's another combination. Guys, you're gonna be doing this until 1 million passwords. I guarantee you that one of them is going to unlock that iPhone. I think the only problem is that the iPhone is not gonna allow you to fail so many times. It just clears the data. Hey, but then hey, that is what is happening there, guys. So the thing is that what we did here, the digits are allowed to repeat, ne? The digits are allowed to repeat. That's why this is quite easy. But what if digits are not allowed to repeat? For example, you can only choose something like 876153, and then you are not allowed to repeat. You see here there are no repeating digits. So how do we know how many passwords are there that are like this, whereby there are no numbers that are repeating? Because these ones, guys, the 1 million passwords, remember, it could be a password like 222137 or 222222, because the numbers are allowed to repeat. So all of these are part of the 1 million, okay? But then what if the numbers, they are not allowed to repeat? Well, if they are not allowed to repeat, well, now you must remember, you want to make a 6-digit password, 6-digit passcode. So you have to have 6 spaces. So that is 1, 2, 3, 4, 5. We need the 6th one. So here the digits are not allowed to repeat. Digits not allowed to repeat. Now for that, how many are we gonna have? For the first slot, guys, I can choose from any of the 10. So I do have 10 options for the first slot. But let's just say I chose 9 on the first slot. I can't choose 9 again. So that means my number of options are going to be 9 instead of 10. And then let's say here I chose 1 and then here I chose 2. I can't choose 1 or 2 again. So it means my options now are 8. Let's say I chose 1, I 2, and then I chose 3. I can't choose any of them again. So now my options is 7, and then 6, and then 5. Good people, then you just multiply there. The answer that you are going to get is the number of passwords that are possible when the digits are not allowed to repeat. The answer you're going to get here is the number of passwords that you can have to unlock the iPhone, the passwords that are not using repeating numbers. You understand? Passwords in which there are no repeating numbers. Right. So that is going to be you put in a calculator. 10 times 9 times 8 times 7 times 6 times 5. So that is going to be around 151,200 passwords. As you can see, the number of passwords now has decreased because the numbers, these ones are not allowed to repeat. Digits are not allowed to repeat. While the 1 million has digits that are repeating and also digits that are not repeating. Actually, from that you can actually calculate the number of passwords whereby the digits are repeating. Right? Because check, we calculated the number of digits that are not allowed to repeat. The number of passwords whereby digits are not allowed to repeat, they are around 151,200 passwords, and the total number of passwords that are possible is 1 million. So if we say 1 million minus 151,200 passwords, the answer that we're gonna get is the passwords with repeating numbers. And get it, these ones are passwords without repeating numbers. So if you want to know how many passwords have repeating numbers, because this one is just the total for the passwords, it's all of them. It's all. When I'm saying all, I'm saying these passwords contain the ones with repeating digits, contains the one with repeating digits and the ones that are not repeating. And the ones that are not repeating are these ones. They are part of the 1 million. So if you say 1 million minus this one, the answer you're gonna get is the digits with repeating. Is the password with the repeating digits. I hope that we understand. I hope that that is clear. I'm gonna make also an example again. Let's say you have the word let's say you have you want to make a code maybe now for your bank. Now your bank says that you must use they want a 4-digit pin. You want to make a 4-digit pin from, you can choose any number between 0 and 9. How many 4-digit pins are possible in the world? So you say for the first one you have 10 options, you have 10 options, you have 10 options, you have 10 options, right? You can choose any of the 10 from 0 to 9. If you get that, if you calculate that, you get that 10 to the power of 4 is equal to 10,000. So guys, you have 10,000 digit pins that are possible in the world. 10,000 4-digit pins. So if you have a pin that has 4 digits, in this 10,000, what yours is there, it is there. Your combination is there in that 10,000. So what? But remember, here the numbers are allowed to repeat. The numbers are allowed to repeat. Numbers, they are allowed to repeat, which means you can have 444 333. You know, the 444 333. You understand? You can repeat them. So here it's a mixture. If I say numbers are allowed to repeat, I'm saying in here it's a mixture. You have pins whereby the numbers are repeating and pins whereby the numbers are not repeating. So if you want to know how many 4-digit pins are going to have repeating numbers, you would say, if I want to know how many, let me write it here, how many 4-digit pins have repeating numbers, If I wanted to know this, what would I do? I would simply have to calculate the ones whereby the numbers are not allowed to repeat. So I would say those whereby numbers are not allowed to repeat, numbers are not allowed to repeat. How will I get it? I'll say, okay, it's a 4-digit pin. How many options do I have for the first number? I have 10 options. And then if I have chose this number, I can't choose again here. So I'll have 9 options, then I'll have 8 options, and then 7. Then you multiply. Then guys, the answer that you get here, which is 10 multiplied by 9 multiplied by 8 multiplied by 7, the answer that we get is 5040. These 5040 pins, 4-digit pins, these 5040 4-digit pins, they contain numbers that are not repeating. Maybe like you have just like maybe 2176. This is one of the passwords that are in this 5040. You see, so if I want to know now how many 4-digit pins have repeating numbers, these ones, they don't have repeating numbers. So to get the ones that have repeating numbers, I have to say the total minus the ones with numbers that are not allowed to repeat. So those with repeating numbers are going to be the 10,000 minus the 5040. I get 4,960. So these 4,960, these are pins that have repeating numbers. Maybe, for example, 2216 or 5883. These pins are all contained in this 4,960. You see, so when you add the ones that have repeating numbers and the ones that don't have repeating numbers, you get the total number of 4-digit pins that you can have if you want to make a 4-digit pin. I hope we are still together there. Guys, what we're talking about here is something that is used when you look at number plates. In Free State, right? I grew up in Free State. So in Free State, the numbers, the car numbers are like this. For example, you'll find JKL, and then it will say 831, and then it will say FS. It will have a small emblem there, right? And then it will say FS. So this will be the car number plate for Free State, a typical car number plate. Do you know that I can use probability to calculate how many cars can I have in Free State before we change this number plate system? Because if we have those number of cars, right, each one having their own number plates, if we have those number of cars, we have to then, what you call, let's calculate it, then I'll explain what I'm trying to say. It's just that though there are some restrictions when you are naming them, or when let's just say they tell you that the number plates in Free State are like this, but the first letter must start with a J. The first letter must start with either J, N, or M. Ne? This is a restriction. And then they tell you that numbers can repeat. Okay, they tell you that the letters can repeat. The letters can repeat, and then the numbers can also repeat. So using this number plate system, we can actually calculate how many cars can we have that are going to be using this number plate system, right? So how do I calculate this? Guys, you have to understand that I want to have three letters here. So you open 1, 2, 3 spaces. Then I want to have three numbers. 1, 2, 3 numbers. The Free State will always be there. You don't have to count it. So the first letter must be a J, N, or M. Ne? The first letter must be a J, N, or M. So how many options do I have for the first option here? How many options do I have? I can only choose from J, N, or M. So I have only 3 options. You see, I can either choose J, N, or M for the first letter. It's important to remember that for the first letter. But for the second letter, I can now choose any letter. You understand? Because the restriction was placed on only the first letter. So for the second letter here, I can choose any of the letters that I want. How many letters do we have in the alphabet? We have 26 total letters. Ne? 26. So we put 26 here. And even for the third letter, I can choose any that I want. So I have 26 options. What about here? For the numbers, we're told that these numbers can repeat. So it means I can choose any of the 10 numbers here. Guys, we are always working with 10 numbers unless stated otherwise. Unless they tell you that we're dealing with, you can choose these numbers only. 10, 10. So from there, I multiply. Using this, I can get how many cars I can have using that number plate system. 3 times 26 times 26 times 10 times 10 times 10. Okay, so that would be 2,028,000 cars, number plates. You see, those are the number plates that I can have, guys. 2 million. So that means I can have 2 million cars and 28,000 that are gonna be produced in Free State. No, that are going to use this number plate system in Free State. If they find that 2 million cars have been reached, they change the number plate system. That's why in Gauteng, if we can check cars in Gauteng, they have 2 letters here, maybe GN, and then 86, and then it says KL, and then it's gonna have the emblem, and then it says GP. This numbering system, they chose it because it can generate more cars. Ne? For the first 2, we can actually calculate how many cars. Ne? The restrictions are that there are no restrictions. Letters may repeat. And numbers may repeat. Even though I know they might have restrictions, but for our purpose here, we're just gonna say the letters may repeat, the numbers may repeat. So how many letters can I choose here to form? For the first letter, I can choose from any of the 26. Same thing here. Then for the numbers, I can choose any of the 10 for the first number and for the second number. Then for this letter, I can choose any of the 26 letters. Then for this letter, I can choose any of the 26. Now I can multiply and find out how many cars can we have in Gauteng. So I'll say 26 squared multiply by 10 squared and then multiply by 26 squared. Yo, 45,697,600. Right, those are the number of number plates that I can have if I use that system. Now obviously this number is gonna reduce if you start to apply restrictions. Now I've seen that in Gauteng most of them they start with K, some start with M or N, you understand? So those restrictions can bring this number down, but I hope guys we understand in terms of how we do this thing. Now we can also use this counting principle for arrangements. For arrangements. Now this one I'm gonna say suppose you have 3 boys and 2 girls. Suppose you have 3 boys and 2 girls. Then I ask you, in how many ways can they sit on a row? In how many ways can they sit on a row? How do you solve that? Well, you just have to count the number of spaces, the number of seats you're gonna need. You have 3 boys and 2 girls. How many seats are you going to need? 1, 2, 3, 4, 5. You're gonna need 5 seats. On the first seat, any of them can come. It's any of the people here can come and can occupy the first seat. So how many options do you have? You have 5 options. What about here? You have 4 options. No, check. Am I gonna say I have 5 options again for the second seat? Are we gonna say for the second seat there we have 5 options again? No guys, we can't have 5 options. You can't have 5 because if let's say this girl, she's sitting here, she can't sit here again, so I can't say I have 5 options. I have to say I have 4 options. So guys, for arrangement, especially people, they are not gonna tell you that people can repeat, people can't repeat. No, that's not possible. You can't have people that are repeating. You'll only have people don't repeat. So you can have 5 options, and then if one girl or one boy is set there, for the second seat it can be any of the 4 that are remaining. Then if 2 boys or 2 girls or a girl and a boy sit here, you have 3 options for the next seat, 2 options for this seat, and 1 option for that seat. Then you can multiply. Then the answer there is going to be 120 ways. Now guys, if you have a number multiplied until 1 and that number is descending like this, you can actually write this as 5 factorial as 5 factorial. Factorial, this thing here, it's called factorial remember that you use it. For example, if I have 3 multiplied by 2 multiplied by 1, I can just simply call it 3 factorial. If I have 4 multiplied by 3 multiplied by 2 multiplied by 1, I can simply call it 4 factorial, and so on and so on. Name. But what is important is to get the answer correct. Number 2, in how many ways can they sit if a boyfriend and girlfriend must sit next to each other, next to each other. Sorry. How do we do that? Well, the way I solve problems like this, especially on arrangement, I simply say inside, inside, and then I look at outside. So how many spaces are we gonna have? Remember, there are still 5 people, so you're gonna have 1, 2, 3, 4, 5 spaces. Ne? But remember, a boyfriend and a girlfriend, they must sit next to each other. No, yeah, they must sit next to each other. So what I do for those who want to sit next to each other, I'm gonna put a box for them. In that box, I'm going to say, okay, here, since we're talking about 2 people inside this box, and I have a boyfriend and a girlfriend. For the first one here, it could be the boyfriend who sits here, or it could be a girlfriend. So I have 2 options. And then if the boyfriend is sitting here, then the girlfriend will sit there. If the girlfriend is sitting here, the boyfriend will sit there. So for the last seat, I'm gonna have 1 option. You see, that is inside. So inside you have 2 multiplied by 1. That is inside the box, whereby they are sitting next to each other. But then outside, let's understand the following. This box could be here, or the boyfriend and the girlfriend, 1, 2, 3, 4, 5. The boyfriend and the girlfriend, they can decide to sit here, isn't it? Or the boyfriend and the girlfriend, they can decide to sit in the middle, or they can decide to sit here. You understand? So the box can decide to be anywhere of along those spaces. Because of that, we have outside. Guys, outside is quite simple. You're simply gonna count 1, 2, 3. The box, you count it as 1. And you know, the Bible says if you are married with then you and the wife become one thing. So just use that thing. So in the box, you count it as 1. So you're gonna have 1, 2, 3, 4. So you have 4 options. So outside you're gonna have 4 factorial. Okay, inside you're gonna have 2 factorial, outside you're gonna have 4 factorial. Then good people, the answer now is simply going to be the 2 times 1 times 4 factorial, and then you'll get your answer there. 2 times 1 times 4 factorial, and you get 48 ways. 48 ways in which the girlfriend and the boyfriend can sit next to each other. Alright. Then you have other things, like maybe we can say the boys must sit next to each other. In how many ways can they sit if the boys must sit next to each other. They must sit next to each other. Now, please be reminded that we have 3 boys and then we have 2 girls. Now, you're gonna have 5 spaces. 1, 2, 3, 4, 5. The boys must sit next to each other. How many boys do we have? We have 3. I'm gonna circle this box for the boys. This is for the boys. So now here, I can have any of the 3 boys sitting on the first seat, and then if one of them is set there, then I have now 2 options, and then here I'm gonna have 1 option. You see, so inside I have 3 times 2 times 1, which is just 3 factorial. What about outside? Outside, I'm gonna count and say 1, 2, and in the box I count it as 3. So outside I'm gonna have 3 factorial. So guys, the number of ways is simply going to be 3 times 2 times 1 times 3 factorial. Three times 2 times 1 times 3 factorial. So that is going to be 36 ways. Okay, that is going to be 36 ways. I'm hoping that we're getting a sense of how we should deal with this probability, guys. Especially this one with restriction is quite nice, né? Yeah. And then what if the girls must sit next to each other? What do you think is gonna be the answer? If we want the girls to be the girls must sit next to each other. The girls must sit next to each other. Well, 5 again. Remember, you have 2 girls, so the box is gonna be for the 2 girls. Any of the girls can sit here, and then here I'll have 1 option. So inside the box, it's 2 times 1. What about outside? Outside we have 1, 2, 3, and then the box is the 4th. So you have 4 factorial. So the answer is going to be I think we got the answer before 48 ways. So I hope that is clear, guys. Okay, so restrictions, you deal them in that way. We're gonna look at least a past paper on this, just so that you see or get a feel of how they ask questions in the exam. Let maybe take 2020 2022. 2022, there were fire questions there. You always have your 2 marks, hopefully, but the other one now is gonna depend on you. So guys, what you also see from these questions is that this counting principle, it counts for more than, it's not gonna be more than 7 marks. Correct. 7 marks is a reach. I think just 5 or 6 marks, that's counting principle in your exam. The majority of probability comes from your grade 11. So please, if you do not if at any point you don't understand counting principle, it shouldn't be something that you worry yourself to death, né? Just understand that it doesn't take a lot of marks. You need to know your grade 11 probability. That is the most important thing. So here we are. We have flags from our African countries. Oh, not our. Flags from 4 African countries, and 3 European countries were displayed in a row during the 2021 Olympics. So you had 4 African countries, flags from 4 African countries, and 3. 10.1.1, determine the total number of possible ways in which all the 7 flags from these countries could be displayed. Guys, the first question there is always quite straightforward. You need number of ways in which the 7 flags can be displayed. On the row, you're gonna need 7 spaces. 1, 2, 3, 4, 5, 6, 7. Here on the first slot, on the first slot, I can choose any of the 7 flags. You understand? I can choose any of the 7 flags from there, or I can take maybe one African country, or I could take the one from European. So I have 7 options. Then here, if I chose one of them, I can't repeat it again. Because there are only 7 of them. I can't repeat them again. So now it will be 6, 5, 4, 3, 2, 1. So the answer is gonna be 7 factorial. And if you put it in your calculator, you don't even have to write factorial, guys. You can just get the answer. So it's gonna be 50, 40 ways. These are the total possible number of ways of displaying the flags. Understand? Now 10.1.2, it says determine the probability that the flags from the African countries were displayed next to each other. Right. Before we even get to the probability, let's get the number of ways in which the flags from the African countries can be displayed next to each other. So it's going to be 1, 2, 3, 4, 5, 6, 7. Right? We need the flags from African countries to be displayed next to each other. How many are they? There are 4. So I'm gonna group them here as 4. It's like that boyfriend and a girlfriend who wanted to sit next to each other, you see. So it's going to be 1, 2, 3, 4. So on these 4 spaces, I can choose any of the 4 to be on the first slot here. And then I can choose then any of the 3 that are remaining, any of the 2 that are remaining, any of the 1 that is remaining. You understand? So inside the box, what do I have? Inside I have 4 times 3 times 2 times 1. What about outside the box? Outside the box, I'm going to have 1, 2, 3, and in the box I count it as 4. So I'm going to have 4 factorial. So good people, my answer is going to be the number of ways in which they can be displayed next to each other is going to be 4 multiplied by 3 multiplied by 2 multiplied by 1 multiplied by 4 factorial. So you say 4 times 3 times 2 times 1 times by 4 factorial. Guys, the answer is gonna be 576 ways. Now, since they wanted you to calculate probability, remember that probability of an event is the number of outcomes in the event over the number of outcomes in the sample space. The number of outcomes in the event are the number of ways that you got by answering the question. It's going to be the 576. And then the sample space is going to be the total ways whereby there are no restrictions. So it's going to be the 50, 40. Then guys, we just put it in your calculator there. You divide by 50, 40. Then the answer will be 0.11. Then you are done. You got the probability there. You see. So these questions, they are quite, they are not simple. Let me not say they are not straightforward sometimes, but you just have to understand the concept. You see, concept of sitting next to each other and the likes. Right. And okay. And then, like I said, this topic, just try to do maybe past papers, and when you are doing them, yeah, let me say, just look at those kind of like tricky questions, right? We can form a lot of tricky questions from this. For example, mina I can say, what is the probability that the flags from the African countries will be maybe will be in the middle. Yeah, if I ask you what is the probability that the flags from the African countries are going to be displayed in the middle, what are you gonna do? Well, you are gonna say 1, 2, 3, 4, 5, 6, 7, 2, 4, 6, 7. In the middle, it must be the 4 African flags. So you're gonna say, oh, we can't have the middle. No, let me say the European countries must be in the middle. The European countries must be in the middle. Here are they. 3 of them must be in the middle, like that. So you must have 3, and then you will have 2, and then you will have 1. But then, since they must be in the middle, these ones here, they can move around when the African flags. So I can choose any of the 4 here, then any of the 3, then any of the 2, then any of the 1. You understand? So for this one, you are not going to move around the box. You're not gonna say 1, 2, 3, 4, 5, because the box must stay in the middle there. So those that are moving around, you're gonna say outside. Outside is 4 times 3. It's gonna be 4 factorial outside. And then inside is going to be 3 times 2 times 1. So the total number of ways will be 3 times 2 times 1 times 4 factorial. Then you will get your answer, guys. The reason why outside I didn't say 5 factorial counting the box as 1 is because the box must stay in the middle. So if it must stay in the middle, you must leave it there. Don't count it as part of the ones that are outside. But otherwise, guys, I hope that is clear, right? And then just practice more. We are gonna switch to calculus on our next session right now when I send you the link.